Okay. In what number is this? 13b, we've got something called a compound inequality. So it's sort of like two inequalities at the same time. And we can solve this a couple ways. One way is to just solve everything sort of all together at once. So I'm going to start by subtracting 4 from all of these. And we get negative 7 is less than or equal to negative 5x, which is less than 25. And then I got to divide everything by negative 5. Since it's a negative, if you divide or multiply by a negative number, flip the inequality sign. So then this is going to be negative 7 divided by negative 5, which is 7/5, is now bigger than or equal to. And then if I divide this middle term by negative 5, I just get x. And then if I divide that last term, I get negative 5. And I have to flip that sign also. So now I know x is between 7/5 and negative 5. And on a number line, negative 5 is over here somewhere. X is over here, or sorry, 7/5 is over here. The 7/5 is included. The negative 5 is not equal, right? There's no equal sign there. And it's everything in between. So this is kind of the written out, like the algebraic answer, and this down here is the graphical answer. Now, if you had to do this using sign analysis instead, the first step is going to be solve the related equations for the boundary points. So in this case, the related equations are going to be the first chunk here, negative 3 equals negative 5x plus 4. And then the second chunk over here, negative 5x plus 4 equals 29. When you work this one out, if you subtract 4, you get negative 7 equals negative 5x. Divide, you get 7/5 equals x. And then over here, you get negative 5x equals 25. X equals negative 5. So you get 2 points for your boundaries. These are your boundary points here. So we'll put them on the graph. This one was negative 5 goes over here, 7/5 goes over here. And then you test your points. So test like x equals negative 10, and test x equals 0, and test x equals 10, right? Let me move that up, and we'll shrink it down a tiny bit. Okay, if we wanted to test x equals negative 10, we're always going back to the original. So here's the original, right here. And if I plug in negative 10, I got negative 3 is less than or equal to negative 5 times negative 10 plus 4, and I'm checking is that less than 29. So that's going to be negative 3 less than or equal to 54 less than 29, which is false. So this part is not included there. If we test x equals 0, let me shrink that down. Oh. Oh. Okay, if we test x equals 0, then I'm going to do negative 3 and check if that's less than or equal to negative 5 times 0 plus 4, and check if that's less than 29. So that's going to be negative 3 is less than or equal to 4 is less than 29, which is true. So now I know this middle region is covered right there. Okay, and then the last part, checking 10. Okay, so we're checking is negative 3 less than or equal to negative 5 times 10 plus 4. And is that less than 29? So this is negative 3 is less than or equal to negative 46, which is already wrong. So that's false. And then we have to check these endpoints. And so the 7/5, that came from this setup. The 5x, the negative 5x plus 4 compared with the negative 3. If you come back over to the original, that involved the equals dot. So that 7/5 has the filled in dot. Because if you think about where it came from the equation that was related to the one with the equals. The -5 came from the equation related to the 29. The 29, if you come back over here, was not included. So that means that the -5 is the open dot. And so now you can look at this and say, okay, well, it's all the x's between 7/5, and it included 7/5, and -5, but it didn't include -5. So there's the algebraic answer, and here is the graphical one.